Factorizing the quadratic equation. Please keep in mind that I've made this video the way I see fit and not in accordance with any particular syllabus. So please check with your teacher and textbook and don't rely on this video to tell you everything you need to know. In terms of maths notation, this video uses the dot instead of the cross as the multiplication symbol. In video 1 we found the general form of a quadratic equation, which is ax squared plus bx plus c. Two examples of such quadratic equations are x squared plus 3x plus 3 and x squared minus 6x. Notice that in the latter equation, the value of c is 0. Factorizing can, in essence, be described as trying to find what multiplies to form a quadratic equation. In other words, trying to find the equation's factors. The defining property of a quadratic is that it has x squared in it, so each factor of the equation usually involves x. Let's take two examples of the most common types of sets of factors and work them out applying FOIL and remembering to pay attention to positive and negative signs. So we can move from factors to quadratic equations pretty easily. But how do we move back? This is the central problem of factorizing quadratics. Well, it is actually pretty easy. The first thing we do is look for a c value other than 0. The equation on the right does not have a c value. We keep in mind the defining property of the quadratic, which is x squared, which is usually indicative of that x and x have been multiplied. We also notice that in this quadratic, all terms are divisible by x. So we divide by the common factor of x, and the result is the sum of x and 9. Because we can divide x squared plus 9x into x and x plus 9, they multiply to give x squared plus 9x. The factors of x squared plus 9x therefore are x and the sum of x and 9. We might also express these factors as x times the sum of x and 9. We can double check and multiply these factors out to confirm that this works. Indeed, x times the sum of x plus 9 does multiply to x squared plus 9. X times x is x squared, x times 9 is 9x. I may have made factorizing seem more complicated than it actually is. It doesn't take so many steps, and with a bit of practice you can do these in your head very easily. To recap, when c equals 0, the factors are always x and the quadratic divided by x. There's an example below. So when c is 0, we multiply x and nothing with x and something to give us the quadratic. What about quadratics in which c is not 0? The main question of factorization stays the same. X and what multiplies with x and what else to give this? So let's tackle these, kind of as if we were reversing FOIL. Step 1, 2 brackets. Step 2, insert x's. We know each bracket contains an x, because there's an x squared in the quadratic, which means that x is probably multiplied by x. Step 3, we insert signs. A quick interjection dealing with signs. We have to remember the rules of positives and negatives when multiplied. We know that in this case, both signs in the factors are positive, because all signs in the quadratic are positive. For reference, when both signs in the quadratic are positive, both signs in the factors will be positive. When the sign for b is negative, but the sign for c is positive, both signs in the factors will be negative. We will come back to the issues of when a is negative and c is negative, but b is not, later. Now, back to our set of factors. To complete them, we have to insert numbers into those two empty spaces, which is easier than it looks. We look at the c value, 12. From FOIL, we know that c is the product of the last two terms of the factors multiplied, and we also know that b is the sum of those two terms added, assuming a is 1. So we just look for numbers which multiply to 12. Then we have to consider that the two numbers have to add up to 8, because both of these numbers will be multiplied by x, and like terms will add in this case to give 8x. This is from the outer and inner stages of FOIL. Consequently, the set of numbers which fits this is 6 and 2. They multiply to 12 and add to 8. So the factors of the quadratic x squared plus 8x plus 12 are the sum of x and 6 and the sum of x and 2. We can double check and multiply them out using FOIL. We get the original quadratic, so that's good. A confirmation that the factors are correct. What if things get difficult? This quadratic stands out because it has a negative value other than the 1 for the a coefficient. There are actually several ways to approach this. We will use the most efficient path. We notice that we have like terms in this quadratic. Negative 3, 6, and 9 are all divisible by 3, We can reduce the complexity of this quadratic by dividing by 3, which gives negative x squared minus 2x plus 3. This has just become much easier. We can place the x's and one of them will be negative because the a coefficient is negative. Then, because the c value is positive but the b value is negative, we know that the two signs in the factors will be negative. So we can place those. Because the c value is 3 and we know that only 3 and 1 multiply to give 3, we know that the two latter numbers of the factors will be 3 and 1, but in which order do they go? Well, we can guide ourselves by the b coefficient of negative 2. Keep in mind that 3 and 1 have to add to give negative 2, so therefore 3 must be negative and 1 must be positive, as negative 3 plus positive 1 will give negative 2. The coefficient negative 3 we can get by multiplying negative 3 with positive x. We consider FOIL as this corresponds to the inner step in negative x minus 3 multiplied by x minus 1. Meanwhile, negative x multiplies with negative 1 to make positive 1x. This corresponds to the outer step. So the result is negative x minus 3 multiplied by x minus 1. This gives us negative x squared minus 2x plus 3. However, we need to return to our original quadratic, so we must multiply by 3. The intermediate step is putting a 3 in front of the factors to denote that they're being multiplied by 3, and then we multiply them out. Notice that we only multiply the first bracket by 3. If we multiplied both the first and the second bracket by 3, we would effectively be multiplying the factors by 9, and we don't want to do that. Finally, the factorized quadratic is negative 3x minus 9 times x minus 1. But what if we couldn't divide by 3 in the start to reduce the equation's complexity? In this case, we now have several variables to work with and we need to take a trial and error approach. We write down the possible factors of a and c, and then test them out to find a working combination. This is a good test of whether or not you've understood how to factorize. Just a hint, there is more than one set of factors which produces this quadratic. Now let's take a look at some more cases. What if b is 0, like an x squared minus 4? Let's think about this in terms of FOIL. The b value is always the sum of the outer and inner stages of FOIL. Therefore, when b is 0, this means that the sum of the inner and outer steps is 0. This may mean one of two things. The first possibility is that both numbers could be 0, but this is not possible as we have a value for c, 4, which is the product of these two numbers. The second possibility is that the two numbers add up to 0. For that to happen, they have to be the same, and one has to be negative, whereas the other is positive. So we know that the factors are in the form of x plus blank multiplied by x minus blank. We know that the same number must go into the blank spaces. We can figure out which number this is quite easily, because we know the c value, which is the product of these two numbers. Because the numbers are the same, the c value is that number squared. So we take the square root of the c value, which results in 2. We insert this, and the factors are x plus 2 multiplied by x minus 2. You can test it yourself, it's fairly simple. Let's take a look at another case. What if b is positive and c is negative? This seems quite mind-boggling at first, but don't worry, it's actually quite easy to tackle. Our example here is x squared plus 8x minus 9. If c is negative and a is positive, which is the case here, this means that one of the signs is positive and the other is negative. So we can establish some components of the factors already. X minus blank multiplied by x plus blank. To make b positive, we just have to make sure that the number following the positive sign is greater than the number following the negative sign because we will add them. We'll quickly consider numbers that multiply to 9 and realize that negative 1 and positive 9 will add to 8 and multiply to negative 9, so we just insert them as appropriate. And our factors for this quadratic are x minus 1 multiplied by x plus 9. We have thus factorized quadratic equations of varying complexity. To recap, factorizing is finding the two sets of factors which multiply to give a particular quadratic equation. We achieve this by asking ourselves the central question, x and what multiplies with x and what else to give us this. This video is registered under Creative Commons 3.0 BY-NC SA license, which means that you are free to download, remix, and share this video as long as you give credit to youtube.com/understandingmaths, and your creations, adaptations, or copies are distributed non-commercially under the same license.